twice as much as an exam, but it's in the 40% column instead of the
That's
test
a whole
column.
different column.
Yeah, it's something similar to that. It weighs a lot because it's its own column being averaged in with your grades, so you need to do well on it. If you're like borderline, like some of your report card grades or something like that, and then you blow the semester exam, like I had a student that went into the semester exam with an A average on all of his report cards. He blew the semester exam. I mean, like blew it, failed it, and it brought his whole average down because he's the one that used the calculator through the whole thing and was done in like 45 minutes, where the rest of the class was still working. Took almost a whole 2 hours. Some came back during ancillaries and kept working. He was done like in 30 minutes or so and did everything on the calculator, because you can use your calculator, and he failed it miserably. And he was shocked, and he goes, but he entered stuff wrong in the calculator. He rushed, he was overconfident, and he blew his whole average.
Did he fail this
He didn't fail, but it hurt him because he was in high school taking this course, and he was going to go into another high school, and he needed that for some dual credit thing, and it gave him an average that was low enough that they wouldn't give him the dual credit or something like that. So you don't want to blow off the semester exam. Okay, I have to start.
Did you fail a semester? Did you fail a year?
You don't fail a year, but you have to repeat algebra again. Especially since all y'all are going different places. If you even fail a semester, there's a possibility that you'll, at your next school, have to repeat Algebra 1. So you don't even want to fail. This goes on transcripts for college, this class, because it's a high school class. So y'all don't want to blow this class off. Okay. Graphing lines. Guys, y'all did this over and over and over again last year. This is going to be, there's little details that y'all probably forgotten. It's going to be like a refresher course, okay? You need to be careful with your graphs. Some of y'all are getting sloppy with your graphs. If we're graphing, you are using graph paper, and each line, like for example, you don't have to write this, but your graphs had better be, your Cartesian planes better be close to perfect. Each line is going to be a number, 1, 2, whatever. The only time you're in between these lines is half marks, okay? And you better be consistent on your graphs. If you try to freehand it, or I see a bunch of little lines or something like that, that ain't going to fly. Especially with this chapter, because you've got to give the slope and stuff like that. And if you are sloppy, your answers will be wrong. I will not accept. Even if you give me the correct answer, if your graph is sloppy, I'm marking it wrong. Okay? This is Algebra 1. You've got to have good looking graphs. And if you notice, and y'all probably remember this from last year. Where did it go? This, and it's for another chapter, but this right here took almost the entire page. Y'all remember, we kill trees, and you could have maybe one graph per side, maybe if you're lucky 2, but it's okay. I would much rather you staple a book of papers and everything be just perfect on your graphs and everything, then you try to squeeze it all in, which, man, I got some 6th graders that, I feel sorry for their Algebra 1 teachers. It's going to be ugly. They want to squeeze everything in like this corner, like all their notes and everything. And I'm like, what's that?
Like it looks
like 2 pages of notes will be right up here.
Like it puts Taylor to shame.
Oh yeah, no, you guys, I'm not worried about. Taylor, I'm slightly worried about, but when it comes to like graphs and stuff like that, he's pretty particular. But no, I'm not worried really about anyone in here. Some of y'all are starting to get a little sloppy and lazy with your graphs, and I need y'all to get back to the way y'all, supposed to be. But some of the other students are gonna have to.
Their notes are literally like shading a corner of the
Yeah.
paper. I can't even read
All right,
anything.
linear functions or linear equations. Every time, linear equations, every time you see the word linear functions or linear equations, and you're like, man, I don't remember what that is. We're dealing with lines. It says it in the word, in linear. Linear equations, linear functions, we're dealing with lines. And I'll put my posters up if I can remember later on. All points that satisfy them form a straight line. Blah, 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 blah. That means any ordered pair that works with the equation will form a straight line. Y'all were doing the last chapter, you were doing functions. You were graphing different kinds of functions. If you remember, their lines were kind of like this. Remember? They were rounded. Sometimes they even went like that, and you're like, is that a function or is that a relation and stuff like that? You did the vertical line test and stuff. Those are different. Those are not linear functions or linear equations. That's why they had curves and stuff like that. But these I like better because if we're dealing with this whole chapter, dealing with linear graphs, and you start graphing something and it turns into like this, you have done something wrong. Because anything you graph in this chapter is going to be a straight line. So if you're plotting points and you don't have is not forming a straight line, you have done something wrong. That's what's great about this chapter is you can actually check yourself when you're graphing. All right, this isn't forming a straight line. I've done something wrong. So that's what that means. All right, this I can't stand. Very seldom is it even used, but I need to teach you anyway. Standard form. I've even hesitated even teaching it, but I've got to introduce it. Standard form for a linear equation. Very seldom used.
Why is there 2 stars on
Because my students will forget about this because it's not used as much. And in the directions, sometimes they'll say, put this in standard form. And my students are like, well, I don't even remember what standard form looks like. So I have 2 stars there to help you find standard form. And it looks like this. AX plus BY equals C. Where whatever the letters represent numbers, your X plus your Y equals the number that doesn't have a letter.
This reminds me of like the equation for hypotenuse and times.
Something like that. A, B, and C represent any real numbers. Now here I have 3 stars. The AX should never be negative. If you get a negative AX, you need to change it. And y'all remember how to do that, and we'll practice that. AX, that says should, but it can't be a negative. If you get a negative, like 5x here, oh man, we got to make some changes there. And we'll go through that. Another 3 stars. So these are rules you got to remember. No denominators. If you get denominators, then we got to make changes. This isn't as difficult as it sounds. To me, it's a waste of time, but
Can they be definite?
I'm going to show you. So, this is the standard form. You know what form y'all are used to? Anyone remember? What is the most common form to graph lines? Y equals mx plus b.
That's a form?
Do you remember y equals mx plus b from last year? Okay. That is what y'all use all the time. That's what you use. This is another form that is dumb. Not used as often.
Even though it's called standard form.
Right.
It's not the standard.
And in fact, tomorrow you're learning about slopes.
Why?
So that tomorrow gets into stuff that y'all probably will all remember. Okay? All right. Example. Y equals x plus 5. Some of you that really remember last year say, oh, it's already ready to graph. Exactly. But let's say it tells you to put in standard form. Let's say they tell you to put this in standard form, which is, again, ax plus by equals c. Again, this, by the time this chapter's over with, by the time this year's over with, you are going to be like, oh, I get that. There's my slope. There's my y-intercept. I can go ahead and graph this guy right here. But today you can't, so put that aside. We have to put this in standard form. So the x needs to be first. Here's your y. And then the 5 is going to be your c. Notice it doesn't have a letter with it, and so it's going to be your c. So here we go. I'm going to rewrite my equation. If I need to have, here's my equal sign. So we need to have the x and the y on the left side of the equal sign. So the only thing I have to move here would be what? Raise your hand. What?
The X.
That's right. Because the y is already on the left side of the equal sign. The 5, which is the c, is already on the right side. So all I need to do is move the x. And I can subtract x on both sides, right? Because we're moving it to the other side of the equal sign. Right, Cecilia? Cecilia, you have a question? Do you have a question? Okay. We have to move the x over here because it needs to be on the left side. So this is a positive x. We're doing trigger alert. We're subtracting. So now I have x, negative x, plus y equals 5. Does everyone see what I did there? I have to get it to look like this format. X plus y equals, c. X plus y equals c. Here's my ax plus by equals c. Now, before I move on, does anyone have any questions?
I hear a ringing.
Nope. Any questions so far? Does anyone see a red flag or problem with this? Gabby. Bingo. Am I allowed to have a negative AX? AX should never be negative. No. You cannot have a negative. Therefore, we have to move it. When we move it, what do we do to the other things in the equation, Gabby? So then this becomes what? Positive. What happens to the y? It becomes negative, and the 5 becomes negative. And there's your answer. That is in standard form. Any questions?
So is this what we're doing today?
Oh, no. Any questions about standard form? Everyone have this? Raise your hand if you're not done. Okay. Graphing a linear function. Okay. Step one. Solve the linear equation for y. This is totally separate from standard. Okay? This is the more usable stuff. So you're going to solve the linear equation for y. Like y equals blah, 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 blah.
MX plus.
No, we're not learning that today. Step 2. This is so dumb. This is like so basic compared to what y'all have already learned. Make a table of at least 3 ordered pairs using, oh, here we go, convenient values for x. Convenient, meaning if x is like, if it's x over 3, why on earth would you choose 2? Because then you have 2/3 and you got to graph 2/3. I would put like 3 over 3, which equals 1. Or 6 over 3, which would equal 2. So if you're, if whatever you're putting in there has like a fraction of a third or something like that, make sure you're choosing x's that make life easy for you, or you're going to really struggle with this. 3, graph the ordered pairs on Cartesian plane. That's that whole, and hopefully yours will look better than mine. So solve the equation for y, make sure it's y equals blah, blah, blah. Make a table and choose 3, at least 3, it can be more, x's. And then 4, since you're choosing the x's, you're going to connect the dots or the points with a straight line. Simple enough, right? Y'all been doing this. If this is like, me, I don't know what she's talking about, as soon as we do the examples, you know it's all going to come together. When you're done, put your pencil down so I know that you're done. All right. I have a star. 2 stars. Y-intercept. Y'all learned this last year. And I don't know why kids have so much trouble with this. It's the point where the graph intersects, or I can say crosses, the y-axis.
So where it goes from negative to positive, or vice versa.
Where the line crosses the y. Write it, and then when you're done, put your pencils down. For example, here's a graph. Here's your y-axis. Here's your x-axis. Where does the graph cross the y? Where does your graph, your line, cross the y? Raise your hand. Michaela? What number is that?
0, -1.
It crosses at -1, right? That's your y-axis. That's it. Your y-axis, or not your y-axis, your y-intercept is where your graph crosses the y-axis, right here. Do y'all understand that? But people have trouble with this. If I say, what's the y, look at this graph. What is the y-intercept? Well, it's right there. Okay, that's it. That's it. There's no tricks to it. Y'all get it? Yeah, okay, we'll see. That's the most important thing. You also need to know the x-axis, but I don't even want to put a star there. Don't put a star there.
X-intercept?
Oh my gosh, yes. X-intercept. See, I'm still on vacation mode. X-intercept. It's the same thing up here, same as above, but on x-axis. Same as above. Don't even need to rewrite all that. Same thing. So write that down, put your pencils down when you're done. See, I'll have an example. Yeah, dude. Look at this. So what is the x-intercept? Raise your hand. Cecilia. Yes, right here. Because this is your x, this is your y. So she's correct. The x-intercept is -3. What's the y-intercept, Emily? Cecilia? 3 is where the line crosses the y.
I was looking at the wrong one.
Which one were you looking at?
The same one, but on the X line.
Okay, so wake up. Y-intercept is where the line crosses the y-axis, right here. X-intercept is where the line crosses the x. Very good. I know, it's Monday. Wake up. Yes,
If it was 0, 0, would it be crossing both of them at the same time?
it'd be crossing right here.
Yeah, so it would be like both of them.
It'd be 0, yeah. All right, good job. So y'all have this written down? So you got it? Okay. Well, if you're writing, I think you're still writing. Okay. Here's a little tidbit of notes. If the equation is y equals any number, it's just y equals any number. Graph is horizontal at that number. If it's x equals any number, graph is vertical at that number. For example, and I'm going to freehand this. Let's say we need to graph y equals -2. X and y. If it's y equals -2, and it says it's horizontal, there's your graph. It's going to be horizontal at -2.
I get it now.
If it's x equals 3, here's my x, here's my y. If x is +3, then your graph looks like that. It's vertical. That's whenever it's just y equals a number or x equals a number. And you're probably going to want those graphs because there's no work involved. All you do is, oh, x equals 3, draw your graph, +3, you're done. Don't need to make a table, don't need to solve for anything, you're done. Any questions on that? When you're done writing it down, please put your pencils down. Everyone done? You good? Open your books quickly to page 235 for examples. All right. 235?
Right,
Yes,
yeah.
ma'am.
Oh yeah. Ooh, still got the wrong page. Okay. Number 1 says make a table of at least 3 ordered pairs, then graph each linear equation on its own set of axes. Blah, blah, blah. Make a table, get 3 ordered pairs, then graph it. 1 is already set for you. It's all, remember, step 1 was to put it in equal to y. Remember? Step 1, solve the linear equation for y. Well, it's already been done for you. So now we're going to make a table. And what 3 x's, because it says at least 3 ordered pairs, what 3 x's should we use? Anyone? Taylor?
-1, 0,
-1, 0, and 1. Let's try it. So we're going to replace the x with -1 and negative, so that's -1 minus 6. What do you get? Anyone?
Makes
Here I have 0 minus 6,
-6,
and then 1 minus 6.
-5.
Okay. So, draw your graph. Oh, wait. What are your ordered pairs? -1 and -7. 0 and -6. And then 1 and -5. Right? So now we start graphing it. -1, then let's see. 1, 2, 3, 4, 5, 6. Oh, that's terrible. And 0 and -6. And then 1 and -5. You should have somewhat of a line. If we were doing it correctly, you would have a line. There's your answer. Any questions on how to do that? Any questions? Do we understand the first section? Y'all understand the first section? Because if y'all have questions, we can do more on this section, but if you understand, you need to tell me if you don't or have any questions. Does everyone understand what we did? Okay. Let's go to the next section then. Did everyone get this down? So the first part, you're just making a table and then getting your 3 ordered pairs and then graphing it, right? All right, the next section says solve each linear equation for y. So 5x plus y equals 20. So all we're doing is solving it for y. Like we're going to have y equals everything else. So who would like to do this? Whit? How do I have y all by itself by the equal sign?
You divide 5 on both sides.
Divide. I just want y all by itself. So do I move just the 5 or the 5x?
Oh, the 5x.
So then, am I dividing?
You're subtracting.
we're going to subtract 5x on both sides. And I get y equals, go ahead and start putting your x's first, negative 5x plus 20. We have solved for y. Any questions on that? Any questions? Either y'all really understand this or y'all are just afraid to ask. Let's do another one. Look at 11. 8x minus 2y equals 14. Michael, I haven't heard from you in a while. Let's solve for y. Tell me what to do.
So if you want to subtract the x,
We're going to subtract 8x from both sides. And I'm left with negative 2y equals negative 8x plus 14. Now what do I do?
you divide 2 y, just negative 2 on this side.
On everything. Now look what I do, guys. Since we are graphing, I'm going to divide negative 2 on each term. Not just one whole thing, but each term. Do y'all see that? Y'all see that? Because we're about to start graphing y equals, what's negative 8 divided by negative 2, Michael?
4
4x
plus 7. I mean negative 7.
So minus 14 divided by negative 2 is minus 7. There's our answer. Y'all see that? Question, Taylor.
Is there gonna be any standard form of the, on the semester exam?
Oh, I doubt it, no.
Thank you.
Okay, any other questions? Yes, ma'am.
So would you do it for all terms if you were like multiplying, or was it just dividing?
If you're having to move something here, you need to do it with every term. But typically it's just going to be dividing. Any more questions on that?
Wait, so if you were like adding plus 2y, wouldn't it just go to the side, or you would have to add it to every single?
If we're adding the whole 2y,
Yeah, the whole
but
thing.
we're not, we want y by itself,
But if you were to,
then it would just be like what we did right
Normal.
here.
okay.
Yeah. Any other questions? All right. You know what? I'm gonna be nice. I don't even like standard form, so let's skip 13 through 16. You're not gonna see that. I don't like it.
Thank you.
I need y'all to learn this other stuff more.
My brain.
All right. 17. I got 2 more problems. I'm setting you free.
17.
Yep. Okay, 17. It says find the x and y intercepts, and yeah, this is going to be on there, of each linear equation. Then use them to graph the equation. Blech. Okay, so you have x minus 2y equals 4. It says find the x and y intercepts. You want me to show you how to do that? Watch and learn. Watch, 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 watch.
Do you write it down while you're doing
Yep. I'm rewriting this equation on 2 sides. Because you need to find the x and y intercept. So when they say to find the x and y intercept, you're going to rewrite the equation here and here. You're going to sub 0 for this y in this one and the x in that one. So now I have 0 minus 2y equals 4, and x minus 2 times 0 equals 4 over here. we're looking for the x and y intercept. So you have it written twice. For this side, I'm subbing 0 and x, and this side, I'm subbing y, 0 for y. 0 minus 2y is just negative 2y, right? Now what do I do, Emily? I'm solving for y. That's right. And I get y equals what, Emily? Oh, look, I had my y-intercept. Cecilia, what is negative 2 times 0? So really, it's just 2x minus 0 is 4, which is really x equals 4, right? There's my x-intercept. Y'all see how easy that was? Now you graph. Y is negative 2. 1, 2. X is 4. 1, 2, 3, 4. And then you connect the dots. Done. So, there's your answer. Any questions? That's how you find that whole section, how you find the x and y intercept. Any questions? None? All right. Look at 25 through 32. Does everyone have this written down? Look at 29. It says graph each linear equation. 29 looks like this. And we've already done this, but look. You go through these. You solve for y first. So we would move the x. And we're left with negative y equals negative x plus 8. Can I have a negative y? So it becomes y equals x minus 8. Does anyone have questions on that? Anyone have questions? So remember, we already did this. You solve for y, make a table, and then graph. So then you'd make a table. Choose your x's and graph, just like we did for number 1. And I'm just going to stop there, unless someone has questions.
So you choose your own
Yeah.
answers? Do you have any recommended ones, or like the same from
No.
the last chapter? Like
Yeah.
negative 2.
Don't you graph it?
Yeah. Any questions? It's going to be done just like number 1, but make sure you put it in y equals something first. Follow these steps. Any questions? All right, you're going to be doing page 235. You don't have a whole lot of time left, so I'm not going to give you too much. I'm going to go backwards. 1, 2, 3, 4, 8. How about 10 problems? Numbers 10, 12, 18 to 32 even. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 9, 10. And today, because of time, that's gonna be for everyone. Due Tuesday. Okay? 10 problems. Because short on time.